how turning CO2 into rock can literally help save the planet. Every country in the world, rich and poor, uses concrete. A staggering 55 billion tons of quarried rock are consumed annually to make this ubiquitous building material, a number projected to double by 2050. We spend about $1 trillion on that quarry rock every year. Around 70% of the rock used in construction is limestone, and limestone is 44% carbon dioxide by weight. Carbon sequestering rock may sound like a futuristic concept, but it's actually a process that nature has used to capture and store CO2 for billions of years. Using carbon capture techniques and turning CO2 into synthetic limestone is an idea whose time has come. By taking carbon dioxide from industrial exhaust or directly from the air, we can transform a greenhouse gas pollutant into a valuable raw material for making limestone-based construction materials. The synthetic limestone industry is poised for major growth financially and environmentally. Synthetic limestone is more uniform and easier to engineer to precise specifications than quarried rock. It has earned exceptional ratings and high scores in safety and quality tests from independent third parties, sometimes far exceeding typical requirements. One of the key advantages of synthetic limestone is that the carbon capture and utilization process removes CO2 from the atmosphere permanently. With quarried limestone, the CO2 is re-released during demolition and breakdown of concrete over time. Synthetic limestone keeps captured carbon locked away for centuries or longer. Additionally, the production of synthetic limestone has a vastly smaller environmental footprint compared to quarrying and transporting natural rock. It can be manufactured on site at construction projects using local sources of emissions, dramatically reducing transportation requirements. Synthetic limestone could help address climate change on a massive scale. Cement production alone accounts for about 8% of global CO2 emissions. If the industry shifted towards using synthetic limestone made from captured carbon, it could remove billions of tons of CO2 from the atmosphere annually. However, once buildings and structures are constructed with this incredible material, they still need protection against long-term degradation. This can be accomplished through eco-friendly coatings and the right green coating encasement systems, providing sustainable defensive barriers for extending the lifespan of these carbon-capturing concrete structures. The technology to turn greenhouse gas pollution into one of the world's most ubiquitous building materials has arrived. Synthetic limestone gives us a way to stop adding CO2 to the air while putting it to use, creating the rock literally holding our world together. To sum it up, turning greenhouse gas pollution into rock may sound like science fiction, but it's a reality with synthetic limestone. This carbon-capturing building material offers a concrete solution to climate change while providing an engineered alternative to quarried rock. With an exceptional safety quality rating and uniform properties, synthetic limestone outperforms natural stone. Its production removes CO2 permanently, unlike demolition emissions from traditional concrete. On-site manufacturing using local emissions drastically reduces the carbon footprint. If adopted by cement companies, 8% of global emissions, this technology could remove billions of tons of CO2 annually. Pairing synthetic limestone with eco-friendly, long-term coatings creates sustainable, long-lasting structures. A true game changer for construction and the environment. Read more about this important subject in Peter Fikowski and Carol Douglas's consequential book, Climate Restoration, the Only Future That Will Sustain the Human Race. You may like this quote from Francis Beinecke, environmental activist. I have long understood that climate change is not only an environmental issue, it is a humanitarian, economic, health, and justice issue as well. What are your questions about this episode? We are always here to help and excited to answer them. Thank you for listening and see you on my next episode.